guys. Finally got this working. Figured out the problem last time was I didn't have the microphone options on. So, yay, Mrs. U-Haul. So, hopefully today I'll be able to explain all of this stuff again. I might do it in segments here so that you don't have one big, huge, long video. So, bear with me as we go. All right, so first thing we're going to start with is adding and subtracting integers with common denominators. So if you remember correctly from last year, you learned that when adding and subtracting with fractions, you need a common denominator. Not the case with multiplying and dividing, but you do need it with adding and subtracting. So I'm going to make this easy. It's going to be kind of a building unit. So we're going to start the very first day with those common denominators. I'm going to give them to you. Then we're going to throw in the uncommon denominators. Then I'm going to throw in mixed fractions, and then we'll kind of do all of it. That's the idea here. Then we'll move on to multiplication with fractions, and then mixed number multiplication with fractions, and then division with fractions, mixed number division with fractions, as well as a couple different methods of division. And all of this is with positive and negative fractions. Mostly negative, this is the new part, because you've already technically done positives. All right, give me a sec to close the door here. I don't want people to hear me talk to myself. All right, so if you look at the board here, 3 is our common denominator. Anytime you have a common denominator, you just go ahead and add or subtract across the top. There we go. So I kind of covered up the negative there, so let me erase that so you can easily see them. So up top we have -4 minus -5, right? All those symbols go up to that top row. So that double negative will cancel and become a positive. So we have a -4 plus 5, which ends up being a positive 1 over 3. Now, at the end of all of these fractions, you need to ask yourselves, can I simplify? Can I simplify? Usually, as long as you have a common denominator, you won't always have to simplify, but you might. So you always need to ask. So can I simplify 1/3? No. So that is my final answer. All right, 1/2 plus -3/2. First question, do I have a common denominator? Yes. All right, so I'm good to go. So I just add or subtract according to the top. +1 and a -3. Different signs, so we're going to subtract those numbers. And we'll end up with a -2 over 2. Now this time it's actually not my final answer because -2 over 2 can be simplified. That means we can divide the top and bottom by the same number and get a smaller answer. So I'm going to show you kind of the intermediate step once, but you don't always have to do this step. So here, divide top and bottom by 2. I like to do the divisibility method, so you will often see me doing that as well, by the way. Because for me, I'm really good at my division. If you have practiced the prime factorization method, go ahead, use what works for you. -2 divided by +2 is a -1, and then a +2 divided by +2 is a +1. And again, -1 over 1 is just -1. Now, if you're comfortable, if these are small enough numbers, you're probably okay. Going from here and skipping straight to the end, that is fine. That is just fine. If you ended up giving me this, it's okay, but you really should simplify it to that whole number. Okay? All right, looks like we are moving to uncommon denominators. So -5 plus -10 over 9. So if you recall correctly, you need to make sure we have fractions. We need to add fractions. And -5 isn't a fraction. Now, I can make it 1 by putting it simply over 1. And to find a common denominator, you have to look at the 1 and the 9 and think, what number do they both go into? The answer would be 9. Well, to get that, you have to times that left number there, top and bottom, by the same thing. To get 9, you times 1 by 9. So you have negative 45 over 9 plus a negative 10 over 9. Now we have the common denominator we can add across the top, which is negative 55 over 9, or, as a mixed number, negative 6 and 1/9. Okay? So nothing needs to be simplified, because if I look at this negative 6 and 1/9, they can't get any smaller. So either of these answers are fine. Now, as my accelerated group, you could probably look at this beginning, negative 5 plus negative 10 ninths, and say, wait a minute, Miss Hall, both signs I need to add. So why can't I just have negative 5 and 10 ninths? You can. Totally. If you see that shortcut, go for it. But I'm going to try and walk you through the long way anyway. But if you have this, you do need to regroup, because you should see this fraction here isn't proper. So you're writing mixed numbers like that, you always have to change them to proper. So we have to convert this 10 ninths. Well, this 10 ninths ends up being 1 and 1/9. So you add that extra 1 to that 5. You've got negative 6 and 1/9. Same as we got up here, just different method. So this one right here is a little faster. Won't always be, but if you see that, go for it. All right, 5/11 minus negative 3/2. Sorry. 5/11 negative 3/2, right? Double negative, which means they cancel. Yay, love it. All positive, something you should know from last year. First thing you need, common denominator. Now remember, with common denominators, you can always multiply the bottom two numbers together, and that will give you the common denominator. So in this case, 11 times 2, you can always have a common denominator of 22. Occasionally you'll run into something smaller, and the smaller you use, the smaller number in common that you can find, the better, because that means less simplifying at the end. This case, there is nothing smaller. So our common denominator is going to be 22. So again, how do I get 11 to be 22? Times it by 2. But to keep things even, to not change what 5/11 is, we have to do the equivalent to the top. Also times it by 2. So he has 10 over 22. Kind of like the reverse of simplifying. With simplifying, you divide the top and bottom by the same thing, right? It's still the same. Only with common denominator, you have to go the other way, because we want to get things to a point where we can add and subtract them. With 2, to get that to 22, we need to times that by 11. And again, you have to do that to the top then. And 3 times 11 is 33. Okay? 10 plus 33, 43 over 22. Nothing I can simplify here, so this would be my final answer. Or if you like to do it in mixed numbers, you would have 1 and 21 over 22. Either of those is fine. All right, common denominator here. Remember, you could always do, again, 4 times 6 and get 24. No problem with that. However, there is a number smaller that both 4 and 6 go into in this case, and that happens to be 12. So I'm going to show you both, actually. I'm going to show you the bigger one and the smaller one and show you why smaller is always better. So let's start with 24. Change the 4, got to times top and bottom by 6. change the 6 times top and bottom by 4. All right, so add and subtract across the top. 42 plus negative 4, different signs, so we subtract. So you end up with 38 over 24. Looking at that right there, they're both even, so you should automatically know something should trigger in your head. I can simplify this. Because even numbers can always simplify by 2. So as long as you have 2 even numbers, it can be simplified. So that's where I'm going to go with first. So I end up with 19 over 12. I got to look at that again, make sure there's nothing else that can go into both of those. There's not. That's my final answer. And again, or 1 and 7 twelfths. Okay. I'm going to show you the other way. And in case you haven't figured it out yet, notice how my final answer ends in twelfths. So my common denominator that both these 6 and 4 can go into is 12. So if I had done that to begin with, I would be at that 9 over 12, and I would skip this whole simplification step. You do not always get that, but a lot of times you will if you can find that common denominator first. So if I do 12 here, erase this up here, I would have to times the 4 by 3 in this case, and the 7 by 3. And then the 6 by 4, and the 1 by 4. Add or subtract across the top. Again, we have different signs, so we're going to subtract. (21 minus 4). That's not 19. What did I do wrong? Wait, 21 minus 4 is 17 over 12, which is 1 and 5 twelfths. Okay, guys, so we did something wrong. You will encounter this with your work. I know the teacher's not supposed to be doing things wrong, but it's good that you can check your work. 7 times 3, 21. 4 times 3 is 12. 1 times 4 is 4. 6 times 7. Oh, that's my problem. Okay, back it up here. Did this wrong. Maybe you caught it already. 6 times 4 gets us 24, not 12. We need to times that by 2. All righty. Let's fix this. So it's 2 over 12. And yes, 21 minus 2 is 19 over 12, which is 1 and 7 twelfths. I will be passing back your homework, kind of like with things just mentioned that something's not quite right. Or I might say simplify if it's just something as easy as that. But because you guys are ahead, I want you to be able to practice finding your mistakes. It's a great tool and a great exercise of your brain, looking for those mistakes. All right, 3 and 8. Lowest common denominator here. 24. Happens to be the same. All right, times 3 by 8. Times 8 by 3. All right. Now I've got my common denominator. Add or subtract across the top. Same sign, so we're going to actually add this time. So negative 53. Sorry, my brain was elsewhere there. Can I simplify? Doesn't look like it. 53 looks like it might be a prime number here. I think so. Yep. So nothing we can combine. Or simplify to, I should say. But we could, so this is my final answer, or you can change it into a mixed number. which is negative 2, 48, and 5, 24. So, low battery, better plug my computer in. Yeah. So either of those is fine. All right. Lastly, throwing in mixed numbers before I pause this video and make one for multiplying and then dividing. Okay. I think I have quite a few with mixed numbers too. So, mixed numbers. I am going to show you the way where you need to change your mixed numbers into improper before you solve them. I'm also going to try and go through and show you, if you can and if you want to, how you can just do a common denominator and then borrow and trade. I think some of you could handle it. Maybe you'll like that way better. So, first method. Change this. Whoops. So you remember from your first lesson, looks like it's too high. You remember from your first lesson, you need to times the 3 by the 4, and then add as you go around, times and add. So 4 times 3 is 12, plus 3 is 15 over 4. Now you'll notice I kind of ignored that negative when I was multiplying. I didn't do 4 times negative 3 is negative 12, and then add the 3 would be negative 9. No. So when going around and transferring, changing the notation, you just kind of ignore. You ignore the negative until you've got it improper, and then you put it back. So plus 2/5. All right. Common denominator times smallest common denominator is 20. So times top and bottom here by 5, top and bottom here by 4. Negative 75, and 8 and 20. Okay. Add or subtract across the top. Different signs, so in this case we need to subtract. So that would give you negative 67 over 20. Again, I think 67 is prime, so nothing to simplify. So you could have negative 67 over 20, or negative 3 and 7/20. Just make sure with the mixed fraction that negative is out in front of the 3, not by the 7. That's not proper format. Okay? Now, if you're really good at doing this with trading and borrowing, kind of like with decimals and with normal subtraction, you can attempt to do this without changing it into an improper fraction first. I've never actually taught it this way, so if you don't like it, don't feel bad. Okay, so the common denominator was 20, right? So let's say we changed this before even changing our mixed number to improper. So we'd have negative 3 and 15 over 20 plus 8 over 20. Right? So there's still different signs. We got a negative on the left side there and a positive on the right. So that would tell me I need to subtract. Okay, well when subtracting, bigger number goes on top. Well, that would be this 3. 3 holes is bigger than no holes. So I take that negative, no, not negative. I need to take the 8/20ths away from the 15/20ths, which in this case is 7/20ths. I didn't need to trade, right? 15 was already bigger than 8, so I was good. And then I need to put the mixed number back. So in this case, that was a lot faster. If the 8 was something like 16 or 17, then you have to regroup from the 3. And you can still do that. You guys might enjoy that, might find it faster. Oftentimes, my other kids, for whatever reason, that's a more difficult concept. So we're going to try. I'm going to teach you both ways. If ever you see me only doing one way and you prefer to do the other, go ahead, do it, see if you get the right answer. All right. So try both ways here. I'm going to change it to improper fractions first. Solve it that way. Then I'll go back and see if we can solve it the other way. All right, 6 times 3 is 18, plus 1, 19 sixths. 3 times 1 is 3, plus 1 is 4. 4 over 3. All right. I'm adding and subtracting, so I need a common denominator. In this case, it is 6, not 18. That's really big. Well, 18 is a common denominator, I should say. But you can use 6, but it's smaller. It works better. So this would just stay the same. And this is the only one I need to change. So I got 19 sixths plus negative 8 sixths. Add or subtract across the top. Different signs. We're subtracting this time. We got 11 sixths or 1 5 sixths. Not too bad, not too bad. No simplifying needed, you'll see, because 11 is prime again. Again, if I hadn't used 6, that would be different. I would have had some simplifying, but I always check. All right. Kind of going back to the top here without changing. It's still times top. Oh, not the 6. Sorry. Apologize. Still would only need to change the 1/3. So I'd have 3 1/6 plus a negative 1 2 sixths. Okay. Still different signs, still subtraction. Bigger number would be the 3 1/6. And the smaller number would be the 1 2 sixths. Well, just like anything, I can't take 2 away from 1 with normal subtraction. That doesn't work. So you would need to regroup, right? Change this to a 2, and this becomes 7 sixths, right? Because I took one of those wholes, from 3, and changed that into 6 sixths, but then I added on the 1/6 I already had, which was 7 sixths. It's not a magic formula where you always add 10 with fractions. It's kind of different because it depends on the denominator. So now I can do 7 sixths minus 2 sixths, which is 5 sixths. So again, 1 5 sixths. Same as what I got below. Alrighty. Double negatives here, we like those. Remember double negatives? Change to a positive. Right? So even more, that shortcut method would work really good on problems like these, because if you just find the common denominator and then add the first part, the whole numbers, and then the fractions, regroup if necessary, those work really great. All right. First, changing to improper fractions method. 5 times 2, 10, plus 3 is 13. Over here, 6 times 3 is 18, plus 5 is 23. Okay, common denominator here, 30. So we're timesing by 6 and 5. Let's see, 13 times 6, 18 carry. And then 5 times 20, 30, 15 carry, 115. Wowza. See, the only kind of scary part with this method is you can get big numerators. However, you don't face the weird regrouping that you do with the other method. All right, add across the top. 13, 7, 8, 9, so 193 over 30. Change that to a mixed number would be, let's see, 6. That'd be 180, so, and 13 thirtieths. Again, you can see by the mixed number here that you don't need to simplify. So you can always change it to a mixed number first and then look at this fractional part here afterwards and see, does that need to be simplified? Because it might be a lot easier to simplify that fractional part at the end versus looking at this huge fraction with a bunch of numbers over there. All right, if you wanted to go from here with without changing them into improper. Again, you still need to find a common denominator. That's no ifs, ands, or buts when adding and subtracting. So you've got 2 and 18 over 30 plus 3 and 25 over 30. So you add your big numbers, you get 5. And then your fractional parts, 25 plus 18, 43? Yes, 43 over 30. Now remember, you can't leave it like that because 43 is top heavy. That's not proper. So you kind of have to regroup. Take 30 away, you get an extra 1 to add here. And so you've got 6 and 13 over 30 again. I'm going to see how many more problems I have left here. 1, 2, 3. Okay, 3. All right, I'm just going to rush through this with one method. You do whatever method works for you. Check it at the end. All right? Ooh, actually, I'm going to do both methods on this one. I forgot. What do we have right here? We already have a common denominator. So all I need to look at is same signs are different. They're different, so I need to subtract. All right, bigger number on top. Can I take 1/6 away from 5/6? Yes, that would be 4/6. And can I take 1 away from 2? Yes, also 1. Remember, my bigger number was negative, so my answer is going to be negative. And here I actually do need to simplify. Right? Divide top and bottom by 2. So I get -1 and 2/3. Man, this method's so much faster. Why didn't I always teach them this way? Yeah, probably the regrouping stuff is hard for some. All right. If you do it the other way, change it to improper. 6 times 2, 12 plus 5, -17 over 6. 6 times 1, 6 plus 1 is 7. And across the top, -17 and 7, different signs, we subtract. It's -10 over 6. Again, you can simplify here or you can wait to make it a mixed fraction and simplify. So if you made a mixed fraction first, you'd have -1 and 4/6, just like we did down here. Again, top and bottom are even, divide by 2. And you'd either get the -1 and 2/3 like we did down here, or the -5/3. Alright, no common denominator here. So I'm going to make it into -22 over 9. Remember, 9 times 2 plus 4 plus 5/3. Common denominator here is actually, well, lowest common denominator here is 9. Again, you could do 9 times 3, that'd be 27, but that's more work. Times top and bottom by 3. You get 22 over 9, -22 over 9, that stays, plus 15 over 9. Straight across the top here on this one. Negative and a positive, subtract. Should get -7 over 9. That's it. That's what that simplifies to. Make sure I did my math right here, you guys. One, 2/3. Yeah, I think that's right. I was just trying the regrouping method. I'll just do it real quick. I know. So -2 and 4/9 plus 15/9 if we don't do that. Bigger numbers on top, right? Okay. And shoot. So in this case, this regrouping method here really kind of stinks because if you take one of these 2's out and leave it as a 1, then this becomes 13 over 9, which is still too small. So then you have to regroup again, leaving that with nothing, and then that becomes that 22 over 9, which is what we had over here. So there are drawbacks to this method because it can give you big numbers, but it saves you a lot of this weird regrouping mess, which is why I always teach my 7th graders usually this method. And if you can handle it, you might as well do it anyway. All right. Hopefully this is the last one. Yes. Okay, good. Remember, whole number always over 1. Okay? Common denominator here, lowest common denominator here is 3. This one stays the same, times top and bottom by 3. The other thing I hope you notice, maybe before I mention it, double negatives change to positive. Now be careful with that. That doesn't necessarily mean we add, remember? Got to look at the signs now. Negative 9 plus 4 are different. Negative sign or negative 9 and a positive 4. So you actually end up subtracting negative 5 over 3 or negative 1 and 2/3. Again, if I look at that, can't be simplified. And that is it for the adding and subtracting with fractions. Okay, I gotta stop this recording somehow.